Oke, halo teman-teman, selamat malam. Ya, ini adalah meetup terakhir kita untuk tahun ini. Gitu, kita akan ketemu lagi tahun depan tentu saja. Sebelum kita mulai meetupnya, saya ingin kasih beberapa pengumuman dari CNCF ya teman-teman. Oke, dari CNCF IT. Oke, agenda untuk hari ini kita akan punya community update, gitu, apa yang sudah terjadi selama beberapa bulan terakhir. Kemudian nanti akan ada dua talk ya, satunya dari Kelly from Microsoft. Terus kita juga akan punya Mas Andika dari Illumina. Itu kemudian akan ada beberapa announcement. Oke. Ini ada beberapa update dari komunitas Kubernetes Cloud Native Indonesia. Ini tentang previous meetups. Jadi teman-teman selalu bisa akses materi-materi yang disampaikan oleh para speakers itu di GitHub account kita ya. Jadi ada Cloud Native ID/meetups. Teman-teman bisa cek di sana. Oke. Terus ada ya ini last meetup kita ya. Ini kebetulan yang bawain Mas Bahril sama Mas Sufar ya gitu. Teman-teman bisa cek juga, ini ada di YouTube CNCF kita. Kemudian ya ini ada beberapa community update. Jadi kalau teman-teman tahu ada Knative ya. Nah, Knative ini baru saja join sebagai masuk ke CNCF Project sebagai statusnya inkubator ya. Itu masih belum graduate. Kemudian ada juga KeepCon Europe 2022. Nah, ini ada CFP itu call for paper ya, call for proposal. Deadline-nya 17 Desember. Teman-teman bisa coba untuk apply juga kalau misalnya pengen kasih talk di Eropa gitu ya, di KubeCon Eropa. Oke, without further ado, let's start the first session. Okay, let's invite Jay into the stage. Okay. Hello, Jay. How are you?
Okay. Can you see me? You hear me?
Yes. We are online now. Yeah, I can see you. Looks good.
All right.
Okay. So Jay is an application innovation specialist from Microsoft. He will deliver the speech about developing Java application on Azure Kubernetes service. Okay, Jay, are you ready?
Yes, I am ready. Yes. Yes. Yeah.
Yes. You can probably share your screen or something. Okay.
Right. Share my screen. Can you see my screen?
Okay. Great. Okay.
Okay.
Okay, Jay, the stage is yours.
Okay. Thank you. Hi. Nice to meet you all. It's so sad that we cannot meet in person. I used to go to Jakarta like every month before pandemic. So yeah, I'd love to go back again. Hopefully next year. Okay. So I spoke at various events in Jakarta. So I don't know, maybe some of you might recognize me. Hopefully. Okay. Yeah. So my topic today is about developing Java application on Kubernetes. I don't know why I actually sent the topic as a Azure Kubernetes service. So yes, so basically I will speak. Okay, so today's topic is not specifically for AKS or Azure Kubernetes Service. So most of things I will speak about, those are applicable to the normal Kubernetes users. So just bear with me, okay? So it's not just again specifically for AKS. So practices, the things I will be speaking about is really about Kubernetes itself. So that's a disclaimer. Yeah. So briefly speaking, introducing about me. Okay. So my name is Jay Lee. Yeah, I worked for several companies before. So latest was pivotal. So I was the advisory platform architect. So I did speak a lot about Kubernetes, Cloud Foundry, and Spring Boot, and a lot about like building microservices basically. Then I joined Microsoft last April, so it's about 2 years. At Microsoft, I'm application innovation architect. So I'm mainly handling the microservices, Kubernetes, containers, and DevOps, and etc. Okay. So everything cloud native, those are my favorite topic, and that's what I do every day. Okay. So that is me. Yeah. Before I get started, I want to give you some perspective. Okay. It's not to actually sell anything to you, but just want to tell you about Microsoft as a company, right? So we contribute a lot to the open source community, right? So if you look at the uh, Kubernetes contribution, of course, number one should be Google. Kubernetes is born there, right? So Google should be number one, and VMware, like Haptio acquisition and Tanzu products. I mean, they are doing a lot in the community. And Reddit comes next. I mean, they have their uh, like flagship product called OpenShift, and I like it. And we also have a managed OpenShift on Azure. So Reddit has been a key company behind the Kubernetes success. And Microsoft is number four. So last 3 years we have contributed a lot. And I don't know. I mean, many of the customers they don't understand. Well, Microsoft. I mean, what have you been doing, right, in terms of Kubernetes? And we are contributing a lot. Okay, we do work a lot on Kubernetes internally. Actually, one of the founder works for Microsoft. So yeah, we are very serious about Kubernetes. And the topic today is actually about just developing Java application on Kubernetes. So I cannot avoid talking about this as well. Okay, so Microsoft built of OpenJDK. So we have our own build of OpenJDK. So you see that Microsoft, I mean, you can see that there's a Microsoft build OpenJDK. So maybe I can show you yeah, here on my Mac, I'm using 11, Java 11. You can see that this OpenJDK is from Microsoft. So yes, we are very serious about Java as well these days. And I mean, basically, this is OpenJDK, meaning it's free. There's no cost associated with Microsoft OpenJDK. And the best thing is we provide the commercial support for the Azure customers. So let's say if you're running your application on Azure, and if you're using Microsoft build OpenJDK, you will get the commercial support from Microsoft. Okay. So that's enough for Microsoft. And today's topic maybe is not really related to Kubernetes, but this is a very serious issue. So I don't know if you heard this issue these days recently, like last week. So there was a known issue found from Log4j and has been there for a while. Okay, and I want to give you the very clear information. Okay, because some of the information conflicts with each other, so that you might be confused. Especially the mitigation part, you could be very confused. And I think this is critical thing again, so that I want to talk about this first. Okay. So I don't know if you follow those, you know, CVE issues, but basically there are not only one CVE, but there are two. Okay, so this CVE, so originally, right, this CVE came out last week, and the mitigation was simpler. Okay, so basically you could just put those thing. So basically this is the Java option, right, minus the option. So without upgrading your library version, if you just apply this property, it was mitigated. Or you can just supply this environment variable, right? Environment variable, and you run your container again, the issue was mitigated. But thanks to this new CVE came out actually 2 days back, there's no option other than operating your Log4j, okay, Log4j library. And to be very specific, is that issue has, I mean, is in this jar file, log4j dash code.jar file. So basically, for you to check whether your application would be affected by this CVE, you should just go and check whether you have this dependency. Okay, log4j dash code.jar file. So let me show you something. So I mean, I'll be using Spring. Sorry, so it's not just a pure Java. So it's much easier for me to do. So what I will do is, I'll just generate some project quickly. Maybe I'll just download it here, unzip it, and what I will do is, so I will actually do C, the dependency tree, and grab Log4j. So it's gonna take some time because it's gonna build, it's gonna download the plugins. So just give it a few moments. Maybe we have all okay. Here you go. Right. So Spring Boot application, without, I mean, if you don't specifically use Log4j tool, that jar file, this jar file is not there. Okay, so reason I'm saying this to you is, I mean, don't be panicked. I understand, right? This is a very serious issue. Actually, the like entire IT world is, just upside down because thanks to this issue. And you must be wondering, hey, what I need to do. I mean, I know that this is a serious issue, but what do you need? What do we need to do? So first thing you need to do is, again, you look for this jar file, log4j.core.jar file. So if you see again the basic Spring Boot application, it doesn't come with the this log4j-core.jar file. Right? So you don't have to worry too much about it. But I do believe that a lot of application out there must be using log4j tool already. So those cases, again, you should be very careful. So in this case, right, I want to show you something. Okay, so what I want to do is, I have my Kubernetes. Okay, I have my. So this is my Kubernetes. I'm using AKS, by the way. Yes, this is my Kubernetes. Actually, let me change the context. It's better. So what I will do is, I will actually list all the images on my Kubernetes. Okay, I mean, you can see this is very easy. I mean, very basic, right? I just use the get patch -a, can get the image part. Right. So those are the images that I'm running on top of my Kubernetes. I mean, there are a lot. I see the, Argo CD is there, RabbitMQ is there. I mean, this is very big cluster. So maybe I will just take one of the image from there. So what I'm going to do is, I'm going to use this open source tool called Tribi. It's from the company called Aquasac. Okay, this is like open source. Again, it's free, so you can just download it and use it. And what it does is, it scans your image. Okay, so Tribi image, and one of the images. Okay, this eggboy/sub services. This is the actual image running on my Kubernetes. Okay, right. So actually gives you interesting things, right? So my image, you can see there are a lot of vulnerability. Okay, so total 78 known issues, and 6 high, medium 18, and low 54. So to be okay, so if you're familiar with this security thing, or if you're not, okay, basically if you're not, just bear in your mind, it's very hard to make this zero as a zero. Okay, total 78. I mean, if you are not familiar with this, you could be like panicked, right? Oh, come on! I mean, what's going on, right? It's not safe to run, but basically, it's a bit hard for you to target zero. Okay, so that's why we have this, criteria, right? Critical 0, high 6, and medium 18. Probably makes sense for you to target like high as a zero, critical as a zero, right? Then probably can go from there. And this is very interesting, but because also you can see this is scanning the base image, right? So you can see this is all the Linux, library, right? libc to for your OS, base OS, and etc. Right? libcurses, SSL, we do a lot. Okay, so those are the basic Linux, thing. And interestingly, you can do Java as well. Okay, and you can see, right, this is the log4j, right, CVE 2021 44228, right, 44228, which is this, right. So this has I'm using this image is using 2.13.3, and it's telling me you need to fix this to 2.15. Okay, so this is really critical, right? So those 3V, even it's not from Microsoft. The reason I'm showing you this is probably you wonder what to do, right? So what you can do is just grab all the images on your cluster and like using this type of simple script and run trivia against it, and you can see whether your images are using which version of Log4j, if there's using any. Okay. So yeah. So one last thing again, you need to at least upgrade to the version 2.15. Okay, at least. Previously, the mitigation was guided as, I mean, you can either set one of this and you will be okay. But thanks to this second CVE 2 days back, now you can not avoid upgrading your version. Okay, so make sure that you upgrade the version. And there are different paths for different version. So if you're using actually older version, right, like older than 2.10, just remove the class from your Java file. Okay, I speak enough about this. Yeah, let's move on. Okay, so what could happen is basically this is very interesting. So if you have this CVE, I mean Log4j older version, what could happen is they can actually attack your application just supplying this message, like this disguising, right? It's actually like JNDI lookup. But what it happens is it will actually go to evil.com and download that evil.class, and somehow in your evil.class, if you have this snippet of code, right, it will just erase everything. Right? Maybe it's not a big deal. I don't know. I mean, because we are using Kubernetes, we are using containers. You get rid of every files. I mean, I don't know. I mean, but they can do the different thing, like send the image, send the messages, steal your critical information, right? So yeah, that's what happens with this issue. Okay, let's move on. Yeah, learning curves of this some container orchestration engine. I don't. Okay, so I think we should agree this thing, right? Kubernetes is not easy, right? I mean, I've been doing Kubernetes for last about 4 years, and I have like CKAD, CKS, all three of them, and still to me, Kubernetes is not easy. So yeah, there's a little learning curve, right? Even you go on production, even you spend a lot of time on Kubernetes, it's still things are not easy. Right? It's just for the sake of fun. Okay. So yeah. Right. So briefly talk about AKS. Again, today is not really just about AKS, but what we provide with AKS is, yeah, this is AKS is basically the managed Kubernetes. Right. So we provide you to automate the infrastructure level automation, like provisioning the worker node, patching your worker node, and upgrading your worker node. right? All those things are automated. You can just do it with one CLI command. We can just go to the portal and do it. And we provide all those development tool, which is our main topic today. So we provide the IDE support, and I'm sure you must hear. I mean, you must have heard this thing called GitHub, right? So GitHub with the AKS is actually a very good combination. And I will actually do a small demo today to show you how GitHub can help. The last thing is this is the enterprise grade Kubernetes. So we make sure that we take care of the security, governance, and IDM and access management. So IDM, we have this thing called Azure Active Directory. So you can easily enforce or rollback access to your Kubernetes. Okay, so that's AKS. And okay, so AKS is not just only option on Azure. Okay, when it comes to Azure, and if you want to run Kubernetes, of course, AKS is the best option. For some cases, you might want to use your own version of Kubernetes because AKS as a managed Kubernetes, right? Managed Kubernetes, you should give up on the flexibility. So if you want to use some features, which is alpha or beta, so that you need to specifically touch the feature gate, then you don't have that many options, right? You have to actually install or use the vanilla Kubernetes. And these days, so I don't know if you have heard this thing, but Cluster API becomes 1.0. Basically, it means GA, right? So Cluster API, using Cluster API, you can provision your vanilla Kubernetes easily. Okay, maybe I don't have enough time to show you today. Let's see, but basically using Cluster API, they actually generate this CLD. Okay, you can see this is the cluster. This is Azure cluster, right? This is, again, you can tell this is Azure. And kubeadm control plane, which is Meso node, right? I mean, I wouldn't go too much detail on this, but you see this is a machine deployment. So what happens is, okay, if I just apply this YAML file, okay, so I applied. Okay. Yeah, it's creating, right? It's creating the Azure machine template and etc. So what happens is I go to Azure. Go to resource group. Yeah, so it's behind the scene is actually, okay, so you see this is resource group plus API. So it's creating the virtual network right now. So again, Cloud API is to create and manage the Kubernetes easily, and it's being managed by as the resource of the Kubernetes. And the reason why I'm actually showing you this today is it can actually create and manage the different type of Kubernetes on the different cloud provider. Okay, you can create your own Kubernetes on VMware. You can create your cluster on Azure or Azure Blast or Google. So basically, it's not just for the Azure, but for the every cloud provider out there. So that's why I'm showing you this. Okay, so Class API. Okay, now let's go to the main topic. Okay, developing Java application on Azure. So maybe we should first talk about this containerizing Java application. Okay, so what do you do, right? I mean, how do you containerize your application? So basically, without any tools, you can just write your own Docker file. It's just a Docker file from copy, args, entry point. I mean, I know there's a lot of work, manual work, but I mean, it's doable. And back in the day, that was the only choice. These days, you have a lot of different options. Like zip is one thing, and source to image from Red Hat is mainly the Red Hat OpenShift. So source to image, take your repository and build the image for you, which is very cool. The build kit is from Docker, so build kit is the like next generation of building container, because Docker right? So most of the CI/CD tool out there, like Jenkins, GitLab, whatever it is, internally, right? Previously, they used to use this thing called Docker and Docker. So basically, what you were able to do was you can build the Docker container inside a container. So that was possible. Where the Docker and Docker is basically gone. You cannot do it anymore. And Docker itself is also deprecated, right? It's not there in Kubernetes anymore. I mean, it's still there. Okay, so it's actually like by version 1.24, it will be gone. 23 or 24, Docker runtime will be gone. So again, BuildKit is actually the next generation of building your container inside the container. Okay, so BuildKit is also an option. And if you're curious, actually, I mean, it runs like one of the container. Sorry, okay, I don't have it here. Okay, and so BuildKit is one of them. Then this thing called Cloud Native Buildpack, and this is something I want to show you today. Okay, so Cloud Native Buildpack uh is to basically containerize any application. So you can containerize your Golang, Python, Node.js, and Java first. That's why I'm actually showing you this today. So what I want to show you is I want to actually show you how to use Cloud Native Buildpack, and also together with this, I want to use the Microsoft OpenJDK. Okay, so for that I need some application, right? So I will just make it as big as I can, and I have my sample labs here. So what I'm going to do is I'm going to use this command pack, and maybe this one. Sorry. Okay. Oh, okay. I'll use this one. Yeah. So I'm using this pack CLI to build this container. And I mean, you don't have to understand everything, but basically I'm using this Java Azure build pack. So what happens is when I containerize this application, it will automatically inject the Microsoft OpenJDK, right? So you take this image and you run it on Azure, whether it's again AKS or different services. We have a different platform, okay, platform as a service that to run your containers. So if you run this image, since it's running Microsoft OpenJDK, we give you the commercial support. Okay, maybe I'll just run this for now and show you. Yeah, you can see this is like downloading some file system. Yeah, while we are waiting, I will show you what this is. Cloud Native Buildpack is. By the way, Cloud Native Buildpack is a CNCF project, so it's not just for the specific vendors. And actually, interestingly, Google GKE, I mean Google GCP, they are using this heavily. Okay, they are using this to build the Cloud Run and all those GKE images and etc. Okay, so a good thing about this is it actually have a layered approach, right? So you see, you have a base image as a one layer. You have a different layers. Of course, I mean those are the build packs, okay. And there's another layer for dependencies and app itself, the source code itself. So benefit of doing this is it actually saves you a lot of time to patch in your stacks individually. Right? Let's say if you just want to patch your application, you don't have to build everything from scratch again. You just need to replace the layer, which is an app. And in case you want to actually update your OS image, the base image, you can just do it with using Buildpack. So Buildpack does just upgrade your run image for you. So that's what I will actually show you today. So Buildpack is a very I mean, it's if it's your first time, you might find it hard to understand. But basically, the key message here is to just build the application containers for me. just taking my source code, and end result is my container image. And that's the actual benefit of using Cloud Native Buildpack. So what I will do now is, let's say I have my image. Okay, so I have my Docker registry. We should sign in first. Yeah, you see, right? I'm even Docker, right? Get the latest on the Apache Log4j too. Yeah, this is very serious issue these days. Yeah, let me log in. Okay, so I'm going to use this client IP image, which is which is actually attacks. Yeah, copy this. Yes. Maybe. Okay, I'll just remove this. Download this again. And see the run preview again to see whether this image is safe. Okay. Right. Okay. But there are a lot of things inside, and also you see there's a Log4j issue as well. And this image has like total 96 issues in there, okay, including Java. I mean, it has a lot of baseline OS image, the CVEs out there. So what I'm going to do is, this is actually built like when? Yeah. Oh my God, 2 days ago. This one, but yeah, what I'm going to do is I'm going to actually run this command rebase. So what will happen is it just leave everything intact and just patch the image, the base image, run image. Okay, let's run and see what happens. Okay, it's downloading something. Right, so it's building a new image, saving my image, which is cool. All right, rebased image. Okay, so what I'm going to do is I'll just run preview again. Maybe I'll just grab. Okay. Yeah, I mean you can compare, right? Previously the issue was like 98 or 95. Now after just one command, I'm using Cloud Native Buildpack to rebase my OS image. Now it has about 59 vulnerabilities. So you can see the benefit of using Cloud Native Buildpack, okay? Because some application is too old and nobody has an access to it, and you still need to patch that image because that image has some vulnerability. Right? In this case, without you building the image from scratch again, just use the Cloud Native Buildpack to patch the base OS image. Okay, so yeah, so patching is always easy by using the rebasing. So at least, I mean, not the application itself, okay, but OS you can easily patch with Cloud Native Buildpack, and it provides you the ABI guarantee, meaning the application should run okay. So ABI is guaranteed for the image, base image itself. Okay, and yeah, okay. So that's the Cloud Native Buildpack, and on Azure, okay, like Google does, we have this command called az pack build. So internally, this az acl pack build. Okay, this command here is using. You can see that is using the semantics of Cloud Native Buildpack. So this command is under the hood again using Cloud Native Buildpack to build my source to the container. Okay, so that's that. And the good thing is, let me go to my GitHub repository. This is my music service. If I go there, yeah, so this is the GitHub action, which is a CI/CD tool of GitHub, if you're unaware of this. So inside the GitHub, right, I'm using again, Cloud Native Buildpack, right? So I install Cloud Native Buildpack and log into the Docker Hub, right? Then, I build an app using pack CLI, right? Run pack, right? Basically, I run this command to build and push my container images inside the GitHub action. Okay. And if you're not familiar with GitHub, actually GitHub, we have made a lot of progress. So we do a lot of like security features. For example, maybe I just go back to a different repository. Okay, nothing there. Maybe I go back to my original repository and security, or maybe I go to action or full request. Okay, so here, right, I have two pull requests. It's actually not by me, but you see this is not from me, it's from the bot. So depend.bot is the bot that continuously check the dependencies. Okay, then it tells me, hey, your version, your Spring Boot version is 2.4, but it's too old. You need to upgrade to 2.6.1. And we ran the CI test and looks, it failed actually in the middle. It's not safe to merge. But basically, I mean, it's telling me what to do with my dependencies, right? So it's telling me I need to upgrade my Spring Boot, Azure Spring Boot dependency version from 3.10 to 3.11. Okay, so, and also run the CI pipeline automatically and tell you, right, this is tests succeed but build failed. So I can go and check what just happened to, okay, you can see the reason why it failed because I didn't supply the username and password. Okay, so this is actually kind of support we have for customers on Azure. GitHub is not just for Azure customer, yes, but we do have this CI CD integration with GitHub on also the Azure DevOps. Okay, so that's the thing, and that's the Cloud Native Buildpack. Now we are actually going to speak about this thing called managed identity. So I don't know how much time I have. Maybe I have about, how much time I have? Just want to check the time. Not sure. Can you tell me? Yeah, okay. 7:50.
Yes.
Okay, 8:55. Okay.
Yeah,
Thank you.
8:55. Yeah.
Thank you so much. Okay, cool. Thank you. Yeah. So maybe so this is the sample application. Okay, this is a sample application. I don't think I can actually show you everything today, but we'll see. So basically, right, this app is connecting to the database. So that's a lot of information. You see, this is using the data source. So URL, username, password should be there. Okay, and you can see it's also using Kafka. It's actually using both PostgreSQL and Kafka. And the thing is, right, for me to test it locally, I need to have this URL and password, right? So what we'll do is, let's see if I run this application. Sorry. So what's gonna happen, of course, is it will fail, right? Because you see, inside my application, I don't have, right, it fails. Yeah, URL must start with JDBC. Again, I didn't supply anything inside my application, right? While my application is talking to the database. Right? So what I need to do is I need to supply this information. This is actually online. So you will see the password here. Never mind, I will just delete this database anyway. So what you would usually do? What you usually do is you just use the connection string, username, and password just inside your code itself. Right. So let's go and run this application. Okay, now, right, you can see that it's building the data source connection. Yes. So this is Kafka. Okay. So basically it runs, right? It runs. So let's see. So I have two endpoints, get songs. Okay. So let's say song. Yes. This is fine, right? This is fine. This is totally fine because I'm running it on my laptop. But what I'm trying to say is this part, right? So usually you must use something, right? On Kubernetes, right? You must be using secrets. And if you understand it correctly, secrets is not safe, basically. Secrets is to save those literal strings with the encoding, base 64 encoding, right? So whoever can look inside the secrets can see the actual value. Right? So on production system, I'm sure you don't want to use secrets at all, right? You must be using something else. Maybe HashiCorp Vault is something you can use. Config server is not safe actually by default. You have to secure it, right? Or on Azure, at least, on Azure we have this service called Key Vault, Azure Key Vault. So let's go to my Key Vault. I'm using this Key Vault, App Secret Vault. Okay. Inside the secret, I have my connection URL and password and username. Okay. So what I do is instead of actually having this, I'll just get rid of this and I run it on Kubernetes or AKS, and I use this thing called managed identity. Okay, so managed identity is system credential, basically system ID, system user that can access to the different Azure resources. So let's go here. If I look at the access policies, right? This application, you don't know what it is, but this application can do, get, list, set, delete, recover on the secret, right? This is the secret, right? So you can actually find, you can do RBAC on Key Vault so that you can control who can and who cannot access to the Key Vault. Key Vault again is to store your secret and also certificate, right? In case you're using like Nginx Ingress controller and you want to store your certificate in the secure store, you must use Key Vault on Azure. Okay, you should store your certificate inside the Key Vault. That's the first thing. That's the first thing. And now you have to ask yourself, right? Then okay, that's fine. How can my application access the Key Vault, right? How? Because everything's out there. You need to authenticate yourself so that you can get an access. So Key Vault is the same, right? Basically, there must be some authentication. And how usually the authentication happens with the credentials like username, password, or OAuth2, maybe client credential, OAuth code. I don't know. It could be either of them. So you must be using something at least like OpenID maybe. There are a lot of different ways of doing it. But then what's so unique about this managed identity? What's so unique about it? Okay, what's so unique about it? This is actually bind the identity to your pod. Okay, so you have this managed identity. Okay, let's go back here. So what happens is this managed identity, I'll cluster KV. Okay, as you can see from here, this has an access to Key Vault. Okay, this managed identity. Okay. So if I can somehow inject this managed identity to my specific container, right? Then in entire flow, I don't need to use any username or password. So it's very secure and safe. And whoever has this pod identity working for the pod is the only one who can access the key vault, right? This is the safest way of running your application. Okay, so what happens is, right, I have my MI ready, right, LBKB, and this has a key vault access. So what you need to do is inside the YAML file, you just tell my pod, hey, you need to just label it, okay, label it AAD pod ID binding and use this pod identity MI and the Albe cluster KV, so that this pod, like this pod, service pod, AKS, not AKS, okay, it's not just for AKS again. This is pod identity. You can install it using Helm. Helm is the next topic, right? Identity to bind MI to my pod. Here is actually I'm using Song service so that we can access to the key vault. Okay. So this is actually what's happening here. Okay, my Song service, by the way, is the service running right now. So you can see, let's get the service. So Song service is this one. Okay, it's a load balancer. So I can actually call it. Okay, that's no messages anyway. Yes. But you can see this is actually under the hood. Inside my application, again, I don't have any credentials in there. Nothing in there. I just use the, pod identity to get my pod talking to Key Vault so that it gets the URL and password from there. And it's actually integrated with the Spring context, okay? So that when it boots up, it just gets the information from, Key Vault, and it uses those information, like, again, URL, username, and password to create a connection. Then it starts the Spring application. Okay, so that's what happens. So again, this is not just for AKS. It can be used with your cluster API Kubernetes on Azure. Okay, and this is the highly recommended way of storing your secret and certificate. Okay, so that's the thing. I have like 7 more minutes. I want to show you 2 more things, okay? So in terms of the gateway, okay, let me show you this. I'm sorry. Need to open this thing. So this is actually, you can tell by name, this is a micro gateway. I heard a lot of these requirements from the customer these days, right? They want to use service mesh, and they want to use like API gateway. They are naturally looking at things like Kong or the different solution. There are a lot of engineering, even engineering has one these days. But if you are familiar with Spring Boot and Spring Cloud has this project called Spring Cloud Gateway. And together with Spring Cloud Kubernetes, you can actually easily build, kind of a API gateway, like micro gateway. Okay, it's not meant for the like full scale, like a RPG type of gateway, but you can build very small gateway built with Spring Boot and Spring Cloud. Okay, so I have this entire application running on my Kubernetes. So you can see from here. Okay, so micro gateway is here. Okay, so what I will do is I will run this application, and I use this K8S discovery. This is actually, again, this is the, okay, what happens is I have my micro gateway service as a pod. Then I have actually 2 services in the back, okay? So one is this, and another is, sorry, I didn't actually have a time to draw the diagram, but I have this music service or song service, right, which has their own IP, right? IP1, IP2, that goes to the backend, of course, right? I mean, its own backend. So what happens is I have my micro gateway. The IP is this. Right? The single IP I can connect to either of them. Okay, maybe I'll talk to this discovery service first. Okay, and see what happens. Sorry. Okay, have my URL here. Okay, so this looks very messy. I understand it doesn't format correctly, but basically what it's showing me is it just shows me entire service endpoint on Kubernetes. Okay, so interestingly, right? Previously, if you are familiar with the Spring Cloud concept, where you use like Spring Cloud Eureka, there's another overhead for you to run another service. Where this Spring Cloud Kubernetes with a Spring Cloud Gateway, you don't have to do it because the service discovery is Kubernetes native. Okay, you don't have to do anything. Just goes to the API server and retrieve. Get all the list of the endpoints, like endpoints again. This endpoint, like this endpoint. So you can basically discover the services, on your Kubernetes. Okay, then maybe I'll call this song service and see what happens. Okay. Right. Instead of me connecting those IPs, right? IP1, IP2, I just talk to my micro gateway, and it acts like as a proxy and send the request to those services. Okay. So I have only 3 more minutes. So I don't know if I can show you the demo. But basically, the last thing I want to show you is the KDA. Okay. So if you are familiar with Knative, right? Knative is meant for building the function as a service on Kubernetes. KDA is also very similar, but it supports very specific serves very specific requirements. Okay, so what it does is it scale out and scale down your containers based on something. That something is actually the critical thing. Okay, so let's say you want to build a function as a service, and you want to use a queue as a medium. Basically the eventing, right? Knative they have this concept called eventing. So KDA, you have a scaler, right? Kafka scaler, RabbitMQ, queue or the database. So what happens is it just constantly checked the length of the queue, maybe or checks the rows in the database, and it just, you see from here in the down here, right? It's using HPA, horizontal path autoscaler, to scale your path. All right. Let's say your message is, you know, piling up too fast, so your client cannot handle it properly, right? Your queues, the partition will get bigger and bigger, right? So what this can help is KDA will auto scale your client path, basically the consumer part, so you can catch up on the messages. Okay, so good thing about KDA is again is not just for AKS, is it can be used with any Kubernetes. Okay, you can use with the GKE if you want. You can use with your vanilla Kubernetes, right? So it does do one thing, and it does do one thing very well. Again, it can scale your containers based on the sub party, like queue or things. Okay, so I think that's it for my session. I'm sorry I cannot actually show you the demo, but yeah, I'm more than happy to stay back and take your question. Okay, I'm done. Okay, over to you,
Okay, thank
Pradeep.
you, Jay,
Yeah,
for your
thank you.
inspiring talk. Okay, we'll get you back again on Q&A. Okay, next I will invite Mas Andika. Wait, sorry. Halo, Mas Andika, apa kabar?
Kabar baik. Apa kabar?
Oke, nah, uh, oke, mungkin saya coba ini ya. Nah, berikutnya untuk talk kedua, tadi C udah sampein beberapa tools yang menarik ya. Sekarang kita akan lihat nih satu tool lagi yang cukup menarik juga dari Mas Andika ya. Judulnya nanti Simplify Helm Chart Deployment with Helmfile. Oke, mungkin untuk mempersingkat waktu, Mas Andika boleh mulai talk-nya.
Oke. Bentar ya, saya screen dua. Oke. Ya. Oke. Baik. Oke. Selamat malam teman-teman dimanapun berada. Jadi malam ini sesi saya kita akan pindah gear sejenak biar agak santai. Karena kayaknya udah pada capek, udah malam, udah bisa beraktivitas seharian. Hari ini kita akan coba main-main dengan deployment aplikasi ke Kubernetes cluster dengan tools namanya itu Helmfile. Jadi asumsinya adalah teman-teman sudah akrab dengan Helm charts lebih tepatnya. Jadi Helmfile ini adalah tools untuk untuk membungkus beberapa Helm dan mendeploy Helm tersebut dalam satu command atau dalam satu organisasi. Oke. Baik. Ini agenda kita hari ini. Jadi kita akan perkenalan sedikit. Terus kita akan refresh sedikit tentang Helm charts. Kemudian kita akan masuk tentang Helmfile sedikit, bagaimana Helmfile bisa mengorganisasi Helm charts dan mendeploynya, dan kita akan coba bikin struktur directory yang baik supaya GitHub source control friendly, jadi bisa di-push ke versioning control dengan baik. Kemudian kita ada demo tentu saja. Jadi saya akan coba banyakin demonya, jadi ngomongnya nggak terlalu banyak. Maksud saya presentasinya nggak terlalu banyak itu. Oke, jadi kenalan dulu. Nama saya Andika, dan saat ini saya berdomisili di Singapura. Jadi baru-baru saja hijrah ke sini, tepatnya di April 2018 kemarin. Jadi selama bekerja di sini, saya bekerja di 2 perusahaan. Jadi pertama di sebuah early stage startup, yang kedua adalah tempat saya bekerja saat ini di perusahaan yang bergerak di bidang bioscience namanya Illumina, ya sampai sekarang. Jadi tarik mundur sedikit, saya memulai karir profesional tahun 2007 dan konsisten handle IT infrastructure sampai sekarang. Jadi kerja di Jakarta dari 2007 sampai 2018. Pertama di Detikcom saya kerja, kemudian pernah juga nyicipin di Viva News, di Kompas Gramedia Group, pernah juga di Kaskus, di Tokopedia, waktu karyawan masih 75-an. Kemudian di sebuah startup di bawah grup Jarum namanya Kurio. Hingga kemudian pindah ke Singapura sampai saat ini. Baik. Oke, jadi langsung saja. Malam ini kita akan coba cerita pengalaman ini, bukan pengalaman. Kita akan coba mengangkat sebuah cerita fiksi supaya gampang kita masuk ke teknisnya. Oke, jadi ini adalah, katakanlah siapa ya namanya ya, John. Ya, oke lah, John. Jadi John ini dia pengen rilis sebuah aplikasi. Kemudian dia bikin produk, bikin aplikasinya ya mirip Twitter begitu, jadi orang bisa post. Kemudian dia pengen pakai Kubernetes. Oke, jadi dia mau deploy aplikasinya ke Kubernetes cluster. Kubernetes clusternya kebetulan udah siap satu. Ya, pertama punya satu. Gampang sekali karena masih baru, jadi dia cuman bikin Helm sederhana, terus Helm Helm install dan bla bla bla, selesai. Bisa diakses, dia happy. Kemudian lama-lama dia mikir, lama-lama traffic makin gede, dia mikir, wah kayaknya aplikasi ini doang nggak cukup nih, udah nggak bisa handle. Kayaknya kita butuh caching supaya database-nya nggak berat. Kemudian dia harus juga deploy Redis misalnya buat handle cache-nya. Kemudian Redis-nya juga kebetulan oke pakai Helm aja biar simple juga karena aplikasinya juga udah pakai Helm. Waktu berjalan, traffic makin gede lagi, dia makin gencar marketingnya. Oke, kayaknya kita udah mulai butuh event-driven architecture. Jadi butuh messaging queue, messaging broker. Install lah Kafka misalnya untuk handle-nya buat asynchronous communications. Udah mulai banyak Helm-nya, dia udah mulai limbung karena dia udah mulai harus menghandle banyak Helm. Kebetulan memang karena dia masih sendiri, klasternya cuma satu, masih belum terjadi masalah. Kemudian dia mulai mikir, wah nggak bisa, karena development-nya udah mulai rapi, dia sudah mulai memikirkan multiple environments. Jadi dia harus juga siapkan development environment, development cluster, dia juga harus siapkan staging cluster buat testing, kemudian dia juga harus siapin production clusternya. Dan dia juga masih pakai Helm. Jadi semakin kompleks. Helm-nya jadi semakin kompleks. Oke. Seiring waktu lagi dia mikir, wah nggak bisa nih kerja sendirian. Dia kemudian mulai hire developer yang lain. Kemudian Helm tadi, Helm chart-nya satu, terus inventory-nya banyak, cluster-nya banyak, kemudian juga timnya nambah, maka mau nggak mau dia harus pakai source control. Oke. Dan source control satu, Helm chart-nya banyak di berbagai tempat dan dia harus deploy ke beberapa clusters. Makin lama menghandle banyak Helm, makin susah menjaga konsistensi. Akhirnya dia kenal satu tools baru namanya Helmfile. Nah, kita akan coba rekonstruksi ulang perjalanan si John ini dari deploy sebuah aplikasi sederhana sampai manage architecture yang agak-agak kompleks. Ya, kita anggap saja kompleks gitu ya, padahal ya nggak terlalu kompleks juga kan untuk keperluan demo juga. Oke. Nah, si Helmfile ini sedikit saja tentang Helmfile. Ya, oke. Satu kelemahannya Helmfile itu adalah dokumentasinya memang nggak terlalu bagus. Bukan nggak terlalu bagus. Susah sekali ditemukan. Di ini ada dia ini kan project open source juga. Jadi ada Git project-nya begini dan dokumentasinya cuma begini. Nih, opsi yang bisa lu pakai ini udah selesai, nggak dikasih keterangan-keterangan yang lain. Kalau mau cari sendiri, gitu. Dan dia juga bilang bahwa ini belum stabil amat. Versinya masih belum sampai versi 1, masih 0 titik sekian, tapi dia bilang udah dipakai di banyak organisasi besar di dunia. Tapi jadi oke lah, boleh dicoba kan. Oke, jadi lanjut. Jadi dia deklaratif sama pakai YAML. Jadi tolong jangan benci YAML karena kalau kerja pakai Kubernetes kemana-mana pasti akan masih ketemu dengan si scripting satu ini. Ya pokoknya itu, intinya dia akan wrap up. Saya juga bingung caranya mendeskripsikan Helmfile. Nanti kita akan praktekin aja biar gampang. Oke. Nah, ini bagian yang saya suka. Jadi langsung ketemu demo. Sorry. Oke. Jadi pertama kita harus cek si clusternya. Kebetulan saya pakai pakai Minikube supaya gampang. kubectl get namespaces, alright. Oke, jadi masih baru, masih fresh. Kita coba, untuk aplikasinya kita akan coba pakai, sorry. Ya, ternyata saya belum switch ya screen-nya. Oke, hold on. Saya agak enggak. Oke, kayaknya ini deh. Stop screen, share. Oke, screen 1. Harusnya sini. Oke, right. Oke. Mana nih? Oke. Udah bisa lihat screen ya kan? Bisa?
Sorry, masih belum, Mas
Belum?
Andika.
Oh, coba saya coba lagi ya. Oke. Screen 1 mestinya sini. Halo.
Oke, bentar ya, coba
Halo?
saya.
Oh, kayaknya udah. Good.
Ini masih yang.
Oke. Nah, ini saya mau nunjukin ini. Oke,
sip.
saya gedein. Oke. Ya, terima kasih udah diingatkan. Thanks, Jay. Oke. Ya, kita akan coba. Saya pakai Minikube buat kebutuhan demo. Semoga laptop saya kuat. Oke, ini masih baru. Untuk aplikasi yang kita akan coba pakai itu apa ya? Ini keren ini. Bukan apa ya? Ya, ini ya. Ya, ini aplikasinya ringan. Bisa di deploy di mana aja, dan udah siap pakai, udah siap Helm chart-nya, tinggal deploy. Oke, jadi pertama menurut kata dia kita harus pertama kita harus pastikan dulu saya punya Helm. Semoga punya Helm. Oh ya, ada. Sip. Oke, kita coba repo. Oh, udah ternyata. Ketahuan deh. Ada latihan Helm, repo, update, PAM. Oke. Udah, kalau udah kita coba install. Oke. Pertama harus siapkan dulu namespace. Singkatin pakai K, kubectl, K for kubectl, kubectl, create. Oke, demo. Oke, kemudian Helm install, namespace, demo. Mestinya sih, oke. Kasih nama, demo, oke, ya. Oke, ya ini, ya pertama kayak begini, install pakai Helm. Sangat mudah. Coba dulu, kubectl, port forward, oke, lihat dulu, get services, ya udah ada, namanya adalah, services namanya Kubernetes. Oh, I see. Oke, ya ini kalau kita coba port forward, ini salah, ini demo, oke. Forward port ini ke port saya 8080, oke. Ya, kita lihat localhost. Ya, ini ya kira-kira seperti ini. Mirip Twitter, jadi sebenarnya saya bisa register, saya bisa login, saya bisa nge-tweet sesuatu. It's bukan scope dari demo hari ini. Oke, seperti ini. Kemudian lagi saya pengen coba install, deploy Redis buat handle cache. Tadi misalnya traffic saya udah mulai banyak, database saya udah mulai kelabakan, saya butuh caching. Oke, kita cari Redis misalnya di sini kan, Redis yang oke kan pakai Bitnami ya. Oke, Bitnami itu harusnya sih saya udah punya nih. Oke, oke kan. Oke, langsung saja diinstal. Oops, ya. Oh, tapi Redis agak ribet ya. Demo repository. Oke, kita skip aja. Coba langsung Kafka aja deh. Karena setahu saya Redis itu harus set auth, password, user, dan lain-lain. Oops, nope. Help install. Nope. Oke. Nope. Kafka. Wah, ketahuan deh. Saya habis install banyak Kafka. Oke. Ke database ini. Ya, dari ini aja udah kelihatan sangat ribet. Oke, jadi begitu. Jadi coba kita lihat deh. Helm list demo. Ya, sekarang saya udah punya dua releases, dua services jalan di namespace saya. Ada Kafka, ada aplikasinya sendiri. Lagi organisasi berkembang, terus saya mikir harus sudah mulai nemu solusi yang bagus buat manage Helm chart saya, dan banyak environment baru yang mau saya introduce. Maka saya butuh sebuah tools, dan solusi saya jatuh pada Helmfile. Oke, sekarang coba saya hapus dulu ini supaya gampang. Delete. Oke, semoga benar. Oke. Namanya itu Helmfile. Saya udah siapin di sini di GitHub saya. Jadi kalau mau bisa datang ke sini, dan ini public, bisa dibuka. Jadi, sorry, saya gedein. Oops, ya. Ya, jadi sini ada caranya. Jadi Helmfile ini sebuah binary, jadi nggak perlu compile dan lain-lain. Langsung aja di download, pilih versi terbaru, ganti namanya, pindah ke path, ke USR bin atau yang lain, bisa langsung jalan. Kasih permission yang benar buat executable, nanti dia bisa langsung jalan. Nah, kira-kira anatomi komennya kayak gini. Nanti kita praktekin aja kali ya. Ya, oke. Jadi di sini kalau bisa copy aja kali, biar gampang. Just. Oke. Saya kasih nama helmfile.yaml. Oke. Hapus dulu. Oke. Jadi gini, kita jelasin dulu anatominya. Oke, jadi si Helmfile ini dia akan merangkum semua aktivitas di Helm saya yang saya execute satu-satu tadi ke dalam satu file deklaratif. Pertama, dia akan list dulu semua charts repository-nya. Tadi kan saya pakai dua repository. Yang satu dari ini, si Nicholas Wild ini, sama si Bitnami. Ada dua. Kita kumpulin dulu sini repository-nya. Kemudian releases yang mau saya deploy, saya tinggal list aja di sini. Pertama saya harus deploy Redis kan. Nah, Redis ini release name-nya nanti saya pengen generate adalah Redis dash namespace name-nya. Jadi dia ngikutin nama namespace-nya. Jadi misalnya nanti kita akan coba bikin for the sake of this demo, kita akan bikin beberapa environment, ya katakanlah dev dan productions di satu cluster yang sama. Tapi biasanya prakteknya kita bikin clusternya kan beda, cluster dev sama productions. Nanti kita akan bikin dua namespace, kita akan deploy dua sets of aplikasi ini ke masing-masing namespace dengan satu file Helmfile ini aja. Jadi nanti secara otomatis si Helm release-nya akan ngasih nama Redis dash namespace name-nya, dia akan langsung deploy ke namespace-nya, dia akan bikin namespace-nya kalau namespace-nya belum ada. Nah, ini dia akan kasih chart-nya, values-nya. Values itu adalah kalau kita bikin Helm, kan Helm itu kan Helm charts itu cuman deklaratif instruction aja. Values variabelnya kita harus siapin. Nah, ini nanti kita bisa taruh di values. Secrets ini dia make pluginnya Helm namanya Secrets. Jadi dia bisa mengencrypt string, mengencrypt value, dan nguncinya bisa pakai AWS, KMS, Google punya GCP dan Azure juga bisa. Dan ini pluginnya Helm. Jadi kalau mau pakai ini harus di-install dulu di Helm plugins. Nah, set ini adalah dia bisa ngasih variabel Helm variables-nya untuk dipakai di release ini. Jadi ini untuk Redis, karena Redis itu agak dalam tanda kutip agak ribet. Jadi dia harus saya harus hapus dulu, saya harus disable dulu autentikasinya. Jadi supaya gampang. Kalau enggak nanti saya harus selalu supply password dan username. Jadi untuk demo ini kita disable dulu. Kemudian kedua, saya pengen install Kafka. Kafka juga anatominya sama. Saya juga mau deploy pakai nama Kafka dash nama namespace. Namespace-nya nanti kita supply. Terus create namespace kalau belum ada. Ini chart-nya pakai Bitnami. Again, sama. Nah, ini aplikasinya baru ini di deploy terakhir. Sama kayak begini. Oke. Nah, cara jalannya gimana? Kita save dulu. Oke. Udah ada. Kita udah punya ini, Helmfile. .waml. Cara jalannya adalah semudah ini. Helmfile. Oke, namespace. Oke, saya pengen bikin pertama di jadi enlarge. Oke, namespace pertama namanya dev misalnya. Terus filenya saya sebutin helmfile.waml. Interaktif. Nanti kita lihat interaktif ini keren sekali. Kemudian apply. Oke. Jadi ini command basicnya adalah Helmfile dan apply sebetulnya. Helmfile apply. Jadi dia akan mengeksekusi. Jadi sama kayak apa ya? Kayak keep curl apply mungkin ya. Jadi dia akan mengeksekusi semua yang ada di helmfile.waml ini ke namespace dev. Kemudian dev ini dia akan dikenalin sebagai variabel ini .namespace. Oke. Dan ini interaktif. Interaktif maksudnya adalah dia nggak langsung dieksekusi. Jadi dia nanya dulu, yakin nggak nih gitu. Karena kita akan lihat mengapa begitu. Ya, pertama dia akan eksekusi bagian ini, update repository-nya, kemudian dia akan deploy satu-satu. Oke, nah ini maksud yang saya bilang. Jadi dia menggunakan satu plugin lagi dari Helm namanya div. Jadi dia akan ngasih tahu dulu kita apa aja yang mau dia lakukan. Jadi manifestnya. Jadi apa aja yang mau dia lakukan, apa aja yang mau di deploy. Jadi ini ya karena masih baru semua. Pertama dia ngasih tahu ini namespace-nya, ini kemudian release-nya, dan ini jenisnya, kind-nya. Ini stateful set kebetulan. Kemudian kalau dia mau nambahin service, dia akan ngasih tahu juga ini service-nya. Ini tandanya plus maksudnya ditambah. Jadi sebelumnya belum ada kan, masih baru. Jadi ini semuanya plus. Jadi kasih tahu dulu. Kita bisa cek sama kayak apa ya? Kayak Terraform plan barangkali. Ini bisa inspect dulu sebelum lanjut. Oke. Nah, habis itu ditanyain, nih yang mau di deploy. Saya punya Kafka Dev, Redis Dev, dan aplikasi Dev-nya. Oke nggak? Kalau oke, dia akan deploy. Semuanya, semudah itu dalam satu command. Oke, jadi pura-puranya si aplikasi ini dia ngobrol sama Kafka sama Redis, padahal sebenarnya nggak ada hubungannya. Jadi ya pura-puranya aja. Pura-puranya mereka ngobrol. Gitu. Oke, jadi kita lihat. Get namespaces. Oke, jadi ini dev. Jadi dia di create. Jadi sebelumnya belum ada. Jadi di create. Kita lihat. Saya pakai Kubernetes saja biar gampang. Jadi kita pindah ke namespace ini. Jadi semua yang komen yang saya lakukan nanti dieksekusi di namespace ini. Kalau belum tahu Kubernetes, coba cari deh. Ini keren banget. kubectx sama Kubernetes itu satu paket. Oke. Anyway, kita cek get pods. Oke. Ups, apa nih? Oke, nggak apa-apa, udah ready. Restart sekali nggak apa-apa, kayaknya lagi cegukan. Oke, semua udah diala nih di namespace dev. Jadi kita anggap kita udah punya dev environment, ya kan? Udah keren. Oke, sekarang kita coba ngerubah sesuatu, apa ya? Yang di aplikasi ini kita lihat apa yang bisa dirubah. Sorry, salah. Yang paling gampang, nah kita ngerubah ini aja Kak, gampang. Jadi ada sebuah environment env.tz atau time zone. Jadi dia kita lihat dia apa ya defaultnya. Oke, tadi kasih tahu deh. Ya pokoknya itu. Anyway kita langsung rubah saja, nggak usah lihat defaultnya. Lamaan. env.tz kita akan ganti ke time zone kita, misalnya Asia Jakarta. Oke, gimana caranya? Kita coba di sini. Name apa tadi? env.tz. Value-nya adalah Asia Jakarta. Oke, save. Oke, kita jalanin lagi sekali lagi. Helmfile sama komennya, namespace-nya dev, filenya masih sama, interactive apply. Oke, harusnya begitu. Nah, dia cuman akan nyasar pin yang berubah. Yang nggak ada perubahan, ya dia dilewatin aja. Semestinya begitu, kita lihat aja. Karena ini interaktif, maka oke, jadi ini. Oke, ketahuan. Jadi tadinya default value-nya itu sebenarnya adalah Amerika/Los Angeles. Jadi saya mau rubah jadi Asia/Jakarta. Oke, yakin? Yakin. Jalanin. Oke, done. Ya, jadi semudah itu. Oke, jadi udah selesai. Udah bikin ini, bikin itu, kemudian kita coba untuk apa lagi ya? Oke. Tadi saya sempat bilang bahwa kita akan coba membuat struktur directory yang baik, ya kan? Saya udah siapin di sini. Jadi begini ceritanya. Ceritanya saya pengen dari satu file deklaratif ini, helmfile.waml, saya pengen deploy dengan mudah ke beberapa environment. Saya udah siapin ini contoh struktur folder directory-nya, my super cool app misalnya, di bawahnya ada Helm Force, di bawahnya ada environments, di bawahnya kita udah siapin foldernya ada dev, prod, and staging. Ini maksudnya adalah di masing-masing directory ada service-nya, ada Kafka, ada values. Misal, contoh, di dev, saya pengen ngasih values yang cuman ada di dev. Jadi value-nya cuman akan ngefek ke dev. Jadi nggak akan ngefek ketika saya deploy ke prod atau staging misalnya. Atau saya mau ngasih value di Kafka Productions doang. Jadi nggak ngefek ke dev dan staging dan seterusnya. Kita akan coba bikin adopsi struktur directory ini ke file kita tadi ini. Jadi kita pakai ini values. Jadi values ini maksudnya adalah si release ini dia akan nge-look up values dari file yang saya kasih di sini. Oke, dalam hal ini kita akan kasih ini struktur directory ini. Oke, jadi langsung aja, misalnya Redis ya. Misalnya Redis, kita akan, dia sebenarnya nanti strukturnya kalau Redis dev atau apapun environment-nya, dia strukturnya adalah my super cool app /helmfile/environment/ nama environment-nya, entah dev, PRD, atau staging, /nama service-nya, kemudian values. Oke. Nah, kita coba taruh di sini. Kalau ragu mau nyontek, contekannya ada di mana tadi? Sini. Values. Nah, contekannya ada di sini. Values, mana values? Nah, ini. Jadi ini nama release-nya, namespace dan lain-lain. Nah, ini values-nya, tinggal ditaruh di sini. Dan dia juga support ini. Nanti kita akan pakai ini, environment. Oke. Kita akan pakai ya environment jadi variables, values gitu. Values kira-kira kayak gitu ya. Oke. Apa nanti my super cool app /helm _first /environments / nah, habis environments ini adalah environment name. Kita akan ngambil nama ini dari variable yang kita akan kasih nanti. Oh, sorry. Oops. Jadi ini apa ya namanya? Namespace. Nah, jadi supaya gampang kita samain sama nama namespace dan nama environment-nya. Namespace, kemudian service-nya, karena saya mau Redis di sini, saya tulis Redis dan values.waml. Hal yang sama saya mau pakai juga di sini. Untuk ngeset punya si Kafka, tapi saya di sini saya kasih Kafka karena ini juga punya Kafka. Oke, sama juga di sini. Oke. Ini adalah twt_xt. Ya. Ya, mestinya begitu. Ini kalau saya jalanin, mestinya sih nggak ada yang berubah, karena ini semua isinya masih kosong. Values.waml semua masih kosong. Kita coba aja. Oke. Bagusnya kalau ragu-ragu, kita bisa ngelihat div doang. Nah, gini doang bisa. Oke. Ada nggak yang berubah gitu doang? Kita bisa ngecek, ngebandingin. Oke. Semoga laptop saya nggak pingsan. Oke, jadi semuanya masih sama karena nggak ada yang berubah kan? Oke, lihat sedikit. Saya baru punya dev. Sekarang saya mau coba deploy production. Oke, Helmfile, namespace dev. Sekarang saya mau kasih namespace-nya ini PRD. PRD belum ada, tapi di sini saya punya create namespace true, jadi harusnya nanti dia create namespace baru, PRD, dan dia akan mengevaluasi files ini, Helmfile environment, namespace-nya ngambil dari PRD, dia akan ngambil ini, kemudian nama service-nya, dan values. Oke, again, dari sisi ini masih belum ada perubahan, jadi dia sebenarnya akan nge-deploy yang sama persis dengan dev ke production, karena saya nggak nambahin, nggak ngurangin apa-apa dari dev ke production. All default values. Oke, Helmfile, interactive apply, yes, kita lihat. Oke, see. Jadi dia pertama nge-create namespace baru dan deploy ini /PRD namanya. Oke, untuk mempercepat ini diiyain aja biar cepat katanya. Oke. Oke. Ya, oke, good. Udah terinstall. Jadi, kalau kita lihat cek list namespace, saya udah punya satu namespace baru namanya PRD. Dan isinya adalah dalam hal ini ceritanya adalah environment productions. Oke. Oke, jadi kita akan coba masukkan ke real skenario. Misal, kenapa kita strukturisasi direktorinya seperti ini. Jadi contoh ya, di productions, di aplikasi, kita akan coba bikin replikas jadi 2 lah, karena dia defaultnya 1 kan dia, podnya. Jadi di bawah productions, txt, kita akan coba replikasinya kita jadikan 2, defaultnya 1. Artinya, di environment yang lain, dia akan ngikutin value defaultnya, yaitu 1. Khusus productions, kita jadikan 2. Kan kalau productions, portnya cuma 1 kan nggak pantas. Jadi buat pantas-pantas ya udah 2 lah gitu. Biar kayak mirip production lah gitu. Oke, kita akan coba dulu cek pakai div. Oke, saya juga belum pernah coba yang ini. Ini semoga nggak malu-maluin. Oke. Ya, dia masih ngontak API. Come on, it's coming. Oke, ya. Oh, bisa. Ya, oke. Jadi ini. Jadi ketika saya coba cek differentnya di PRD, di productions, dia akan ngubah replika jadi dari 1 ke 2. Oke. Tapi semestinya kalau saya ngecek dev environment, mestinya sih dia nggak berubah. Saya coba ya. Berapa menit lagi nih saya punya? Kayaknya sekitar 5 menit lagi, tapi it's okay. Ya, dev dia nggak berubah. Jadi cuma productions. Tadi productions baru di div, belum sempat di apply. Kita apply aja. Baik, jadi begitu. Itu udah, coba struktur directory udah. Jadi penerapannya biasanya kita maintain ini, directory structure ini ada di Git biasanya, atau versioning control yang lain lah. Upload ke sana, jadi kita bisa kerja bareng-bareng di sana. Jadi misalkan dev, kita mau Kafka-nya, konfigurasinya gimana, production staging kayak gimana, tapi kita cuma install dan memanage semuanya pakai satu deklaratif doang, si Helmfile ini. Penerapan di real life yang lain, skenario-nya contoh, saya mau nge-deploy sebuah aplikasi, yang di aplikasi itu dia butuh database misalnya. Atau bahkan dia butuh, kalau di cloud kan dia Misalnya butuh messaging brokernya, biasanya kalau di AWS tuh ada SQS gitu. Kalau terus dia butuh IAM role baru sebelum dia deploy aplikasi, bisa juga pakai ini. Jadi di Kubernetes itu coba cari ada namanya kayak Terraform operator gitu. Jadi kita bisa supply variabelnya, TF varsnya, nanti si operator ini akan jalani dulu Terraformnya, siapin semua resource-nya, baru deploy aplikasi. Itu juga bisa pakai Helmfile ini. Jadi intinya kita bisa mendeploy sebuah aplikasi secara utuh dari ujung ke ujung dengan semua resource-nya pakai satu declarative file ini doang, si Helmfile gitu. Dan asiknya lagi, dia karena kita nggak ngerubah si Helm charts-nya ini secara individual, ini bisa dibongkar pasang. Misalnya nih, si Redis-nya saya mau pakai di aplikasi ini dan aplikasi yang lain gitu. Ya saya tinggal pasang aja Redis-nya, ambil taruh di aplikasi lain. Terus Kafka-nya juga ambil taruh di aplikasi lain bisa. Jadi kayak modular sekali, jadi gampang. Oke, jadi itu. Kemudian ada satu caveat sebenarnya, bukan caveat ya. Kalau kalian udah pakai Argo CD atau Flux, jadi ya mending nggak usah pakai ini. Nggak usah pakai Helmfile, karena ya fungsinya mirip, fungsinya sama. Itu aja. Ini untuk ya buat pengetahuan aja. Gitu. Kita lihat, kayaknya udah selesai. Udah. Oke, jadi begini. Oke ya. Gitu deh. Apa lagi ya yang mau saya sampaikan? Kayaknya udah itu aja. Oh ya, supaya asik kita akan coba destroy terakhir. Kan ini ya, yang productions, biar sekali-sekali saya pernah ngerasain nge-destroy production. Interaktif, instead of apply, saya tinggal kasih destroy. Oke. Dia akan ngasih tahu dulu, ini saya mau hancurin Helm charts yang ini, gitu dong. Nanti saya tinggal kasih persetujuan. Oke. Oke, come on. Ya, ini. Jadi ini yang bakalan affected. Bla bla bla, dia want to delete. Saya tinggal bilang iya. Oke, bam. Beres. Production hancur. Oke, jadi kayaknya itu aja dari saya. Semoga dapat manfaat. Kalau masih ada pertanyaan, kita bisa ngobrol di sesi tanya jawab. Kalau misalkan masih ada pertanyaan mengganjal, bisa japri saya. Oke.
Oke. Thank
Terima kasih.
you Mas J. Mas Andika, sorry.
Iya.
Keren banget. Oke, mungkin ini sebentar. Saya akan coba present sedikit announcement ya. Mungkin nanti saya akan tambahkan lagi J dan Mas Andika ke stage. Oke. Kita akan masuk ke sesi Q&A. Oh ya, sesi Q&A dulu ya. Berarti saya langsung aja tambahin. Oke. Hello. So we have a couple of questions. Let me pick some of them. Okay. The first question is from Sufar, and I guess it is for J. The question is, how seamless of migrating Docker file to Buildpack?
Yeah, it really depends on what you do with Docker file. So if it's simple enough, probably you don't need to do anything. Like what I did today, I just containerized my Spring Boot application. So it is simple and straightforward. If you need to install some very specific OS package, for example, then yeah, we need to actually see, right? It's not just a single command. You need to do something more than that. So really up to what you do with your Docker file, basically. But Java, I don't see any problem. I mean, yeah. I mean, there's no like a clear answer, sorry, but it really depends on what you do. You can, you can actually, I can take it offline. You can just, send me a mail. I can help.
Okay. Probably Jay and Mas Andika can also share like your Twitter handle or something so
Oh,
that we can post it on
ya.
YouTube. Yeah, nice. Okay. Uh, Next question is from I don't know who is he. Personal data. Okay. Uh, Hi Jay, can I use Kubernetes Azure for auto scale pod based on traffic load balancer?
Yeah, you're talking about scaling load balancer or scaling pod, traffic load balancer. It's a bit, I don't know. I mean, I don't fully understand the question. Sorry. Auto scaling
Okay.
pod based on traffic load balancer. Yeah. So if you are asking, if you can auto scale your pod by number of requests, for example, Kata has one. Kata can do that. Okay, Kata can do that. Like 100 RPS, requests per second, for example. If you want to scale based on this RPS, you can do it with Kata.
Yeah, the one that can handle the eventing, right?
Yep. Yep.
Okay. Okay. So probably personal data. If you want to elaborate your question any further, you can type in the comment. Okay. Okay. Also, there's another question for
Yeah. Yeah. So Buildpack has a base image, so you don't have to prepare your own image. It it provides the base image, and it also constantly patch the OS image, so you don't have to prepare any image for you by yourself.
Okay. Okay, good. So the next question, I guess this is for Mas Andika. Nah, ini pertanyaan pertama untuk Mas Andika. URL GitHub-nya mungkin bisa
Ya,
ditulis juga, nanti akan saya
oke.
post.
Langsung ke GIS-nya aja ini. Iya, udah saya kasih ya.
Oke.
Atau gini deh, langsung ke GIS-nya aja. Bentar. Ya. Ups. Nih, kayak cuma ada satu kok di situ. Saya di GitHub personal saya jarang update. Nah itu nanti.
Okay, so let's look on another question. Oh, it's from me. Okay, so Mas Andika,
Okay.
di akhir sesi at the end of your presentation, you
Mhm.
talk about Terraform operator and Helmfile, like they can be combined. So can you please elaborate like how to do that?
Oke. Jadi begini, pakai bahasa Indonesia aja ya.
Oh ya.
Oke. Jadi lagi begini. Saya kasih contoh yang saya tahu betul yang saya pakai. Saya mau deploy aplikasi. Di aplikasi itu gimana ya? Saya mau pakai saya ngobrol ke AWS lah misalnya, ke cloud provider. Saya mau deploy sebuah aplikasi yang aplikasi ini harus misalnya dia mau upload pakai mau memanfaatkan SQS atau SNS contohnya, atau misalnya dia butuh IAM role untuk di-assume untuk upload sesuatu ke S3 bucket misalnya. Nah, dia biar aplikasi jalan kan normalnya saya harus pergi ke IAM role IAM dulu, saya harus create role-nya, saya harus ambil ARN-nya, masukin ke IRSA, gitu kan. Masukin ke podnya supaya podnya bisa assume si role-nya ini. Nah, pakai Terraform operator, kita bisa siapkan dulu TF-vars-nya untuk bikin role-nya sebelum saya deploy aplikasi. Jadi di helmfile.waml-nya, di deklaratifnya, di situ tinggal dipanggil aja satu pertama Helm chart-nya si Terraform operator, untuk bikin atau siapin IAM role-nya dulu. Oke. Kemudian baru deploy aplikasinya, dan aplikasi ini akan assume si IAM role yang udah jadi itu. Paham nggak maksudnya? Jadi saya nggak perlu datang bikin IAM role manual, kemudian biar aplikasi saya bisa assume ini. Jadi sekalian aja gitu. Kalau Terraform operatornya sendiri itu ada saya mau sekalian pamer, ada satu bikinan teman kantor saya, namanya bikin Terraform Dash Operator. Namanya Isa Aguilar. Oke. Nah,
Si Terraform operator itu berarti kayak chart juga gitu ya, Mas ya?
iya, itu Helm chart. Betul.
Oh, I see.
Operator.
Okay.
Kubernetes operator. Oh kan?
Oke.
Jadi dia akan standby terus untuk ngejalanin kita kasihnya Terraform variables-nya. Kasih Terraform variables-nya, kasih tahu stack-nya. Nanti si operator ini dia pakai CRD sih, custom resource definition. Jadi nanti dia akan terus-terusan mantengin si CRD-nya ini. Ada perubahan nggak? Kalau ada perubahan, dia akan langsung ambil dan execute.
Oke.
Gitu. Jadi operator.
Ya, make sense. Oke.
Dan ini bisa dideploy pakai si Helm chart. Kalau bisa dideploy pakai Helm chart, kita bisa bungkus pakai Helmfiles juga. Gitu. Jadi sekali deploy pakai Helmfiles, kita nggak perlu manual bikin IAM role-nya, nggak perlu manual bikin SQS, SNS, dan lain-lain. Langsung jalan, semua resource-nya udah jalan. Dan itu bagusnya lagi karena dia operator, dia akan mantau terus ketika kita mau coba istilahnya itu drifting, kita pengen ngerubah itu manual, si operatornya ini akan ngecocokin, wah ini udah berubah nih, dia akan cocokin lagi, dirubah lagi sama dia.
Gitu. Oke. Real time ya kayak ya.
Oh iya, kan operator, dia akan ngecek terus. Iya.
Ya, CRD. Oke. Okay, I think there is no more questions. Okay, if you guys want to contact Jay or Mas Andika, you can just shoot to them at Twitter. They have already shared their Twitter handle. Okay, thank you, Jay and Mas Andika. Glad to have you here.
Thank you.
Terima kasih.
Okay, see you on. Yeah, I hope we can see you offline also. We can meet in person or something.
Yeah.
Oke. Berikutnya saya akan coba untuk lanjutin ke beberapa announcement sekali ya. Nah, teman-teman mungkin aware juga ya. Jadi kalau di Cloud Native ID itu kita fully using GitHub ya untuk apapun gitu. Termasuk kalau untuk Meetup, teman-teman ada usul yang menarik, saya kenal ada seseorang yang melakukan sesuatu yang menarik, atau misalnya saya pengen ada topik yang dibahas nih. Teman-teman bisa sesimpel kayak langsung aja kasih open issue gitu ya, open issue gitu. Nah, ke GitHub kita ya, github.com/cloudnativeid gitu ya. Nah, ini Cloud Native ID ini ada di beberapa kota juga ya, Bandung, Jakarta, Malang juga ya. Oke. Kalau misalnya punya interesting project, teman-teman juga boleh share juga ya. Misalnya, oh ini kayak Helmfile itu kan yang bikin siapa Robosam siapa gitu ya. Itu kan orang juga gitu kan. Nah, teman-teman misalnya berguna untuk komunitas. Nah, itu silakan ya. Terus apa teman-teman mungkin tertarik sama satu company gitu ya. Oh, saya pengen dengar sesuatu dari let's say Nutanix, NetApp, Microsoft, AWS, Google gitu. Teman-teman bisa juga reach out ke kita. Nanti kita akan coba hubungin ke company yang terkait gitu ya untuk kasih talk, untuk ngisi talk di Meetup. Oke, untuk teman-teman yang belum join, teman-teman bisa join di kanal Telegram kita, t.me, Kubernetes Indonesia. Nah, itu All Things Kubernetes, All Things Indonesia di situ ya. Kemudian teman-teman tuh juga bisa pantengin, kita setiap kali ada meetup kita akan selalu upload di meetup.com gitu. Ya ini Jakarta Kubernetes tapi ya karena online juga jadi kita sekali lagi terbatas sama geographical boundaries ya. Terus ini apa namanya GitHub kita yang tadi ya. Oke, teman-teman bisa hubungi, bisa langsung masuk ke situ, bisa lihat juga slide yang biasa di-present oleh kayak tadi C sama Mas Andika present, teman-teman bisa mungkin mau lihat lebih detail, nanti akan ada di situ juga. Oke, tadi ada di awal-awal ada pertanyaan juga soal video untuk CNCF ya. Ya, kita bakal upload tuh, KCD ya, KCD, Kubernetes Community Days itu kita bakal upload. Nanti teman-teman tunggu aja, bakal muncul di YouTube juga. Oke, terima kasih semua. Selamat malam, selamat. Oh, besok masih Jumat ya. Oke, selamat melanjutkan satu hari sebelum weekend dan selamat berweekend. Sampai ketemu. See you.